All right, everybody, this last video in our thermochemistry playlist is to talk about how we can figure out how to determine how much energy it takes to change a substance from one state of matter to another at different temperatures. Okay, so you'll see that this is the phase change example problem number 2 in our notes. It asks how much energy does it take to change 29.0 grams of water starting at 15 degrees Celsius to steam at 155 degrees Celsius. So if we go back to our 5-step phase diagram, okay, so this is our temperature, this is our time. We knew that we had these 5 different parts where we have a solid, where we see our solid melt, where we see our liquid water here, we see it boil, and then we see that we have steam here. Okay, for water, okay, we are going to be melting at 0 degrees Celsius and we are going to be boiling at 100 degrees Celsius. So our problem here starts with water at 15 degrees Celsius, so about right here, and takes me to steam at 155 degrees Celsius, so about here. So we need to figure out how much energy it takes to get from here to there. Well, if you look at the graph carefully, you'll see that you have this section right here where the water is being heated that we need to calculate first. You're going to see that we have this section here where the water is going to be boiled. That will be calculated second. And then you'll see that we have this third section right here where the steam is being heated. Okay, so we are going to have to add up these 3 sections individually, or determine those 3 sections individually, and then add them up to figure out the total. So let's look at exactly that. All right, so the first part of our problem heats water from 15 degrees Celsius to 100 degrees Celsius. What would our delta T be? Delta T is TF minus TI, and that means I have 100 minus 15, so we are going to have a positive temperature change of 85 degrees Celsius. Boiling water to steam, there's no temperature change here, so I'm going to use my Q equals M delta H of vaporization that we went over in the previous slide. And then I'm going to heat steam from 100 degrees Celsius to 155. What's my delta T here? My delta T here is just going to be 155 minus 100 degrees Celsius, which is 55 degrees Celsius. Possibly the most common mistake that I see is people plug in 155 instead of just the 55. All right, so if we look back at our graph here, this is exactly what we see. We are starting here at 15 degrees Celsius and going here to 155 degrees Celsius. So like we said, we need to figure out this first part. Then we need to figure out this second part where we're going to see it boil. And then we're going to figure out this third part right here where we're going to see our substance heat up. So in our first part, we're going to use, since there's a temperature change, Q equals mc of water delta T. In the second part, we don't see a phase change. That's our plateau, Q equals M delta H of vaporization. And then lastly, in this third part where we do see the temperature change, we're going to use QMC of steam now, and that delta T of 55 degrees. Okay, so let's plug everything in. All right, so first things first, we are going to need a couple of those constants that we went over earlier in the chapter. Okay, the specific heat of water, whoops, the specific heat of water is going to be your 4.184 joules per gram degrees Celsius. go. And we are going to write that down. Give me a second here. 4.184 joules per gram degrees Celsius. And our delta T here is going to be our 85 degrees. Okay, we have our delta H of vaporization constant that would be needed, and these are all provided for you. This is going to be 2256.9 joules per gram. And lastly, we need our specific heat of steam, which is another constant, 2.01 joules per gram degrees Celsius. And my delta T here is only 55 degrees Celsius. So be careful with those delta T's. Okay, so plug it in, plug it in. First things first, our 29 degrees Celsius, okay, or 29 grams times 4.184 and 85 gives us 10,313 joules. Members, grams and grams cancel out, Celsius and Celsius cancel out, leaving just joules. Next, with our delta H of vaporization, we have grams and grams cancel out, leaving us with just joules again. And then lastly, for the steam portion, we have 29 grams times the specific heat of steam, 2.01 joules per gram degrees Celsius, so our grams cancel out. And it only went up 55 degrees Celsius, and we get 3,205.95 joules. So if these three are joules, I can add all three up and I get a value of 78,929 joules. But to be polite, I'm going to change it to kilojoules by moving the decimal place 3 times. That's 78.9 kJs, or kilojoules of energy, it takes to go from 15 degrees Celsius up to 100, then to boil, and then to get my boiling 100 degrees Celsius steam to 155 degrees. All right, these are very important calculations that they need to figure out, especially when it comes to energy consumption and making sure that if you have some sort of device and it overheats, that it's not going to melt your device, and you want to make sure that your product is going to work. So engineers definitely use this stuff all the time. Okay, good luck.